Russia's $4.7 billion nuclear torpedo detonates 40 meters from its own submarine. 89 sailors have 11 seconds before catastrophic meltdown. What happens next exposes the deadly truth about Putin's doomsday weapons. October 22, 2025, 4:17 a.m. Barents Sea, 340 kilometers north of Murmansk. The K-329 Belgorod, Russia's most secretive submarine, prepares to test the weapon designed to end civilization. Poseidon, status 6. The nuclear-powered torpedo that NATO fears more than any Russian weapon system. Designed to carry a 2-megaton warhead capable of creating radioactive tsunamis. But in 11 seconds, Russia's ultimate superweapon becomes its worst nightmare. The stakes couldn't be higher. $47 billion invested in Poseidon development over 9 years. Putin personally approved the program. State media called it unstoppable, invincible, the weapon that makes American missile defense irrelevant. One Poseidon could irradiate an entire coastline, make New York uninhabitable for 100 years. This test would prove Russia still builds weapons that terrify the West. Captain Dmitry Volkov had commanded the Belgorod for 14 months. The submarine stretched 184 meters, displaced 30,000 tons submerged, built specifically to carry 6 Poseidon torpedoes in special launch bays. Each weapon measured 24 meters long, weighed 100 tons, powered by a miniature nuclear reactor generating 200 megawatts. Maximum speed, 100 knots underwater. Range, theoretically unlimited. Depth capability, 1,000 meters. No existing torpedo could catch it. No countermeasure could stop it. Volkov studied the weapon specs for the 100th time. The Poseidon used a liquid metal-cooled reactor, highly experimental, extremely dangerous. Russian engineers compressed nuclear submarine propulsion technology into a torpedo-sized package. The technical challenges were immense: cooling system failures, radiation shielding limits, control system vulnerabilities. But Moscow demanded results. The weapon had to work. Previous tests occurred in controlled environments, shallow depths, short distances, simulated warheads. This test would be different. Full operational depth, 200-kilometer range, live nuclear reactor at maximum output. The weapon would demonstrate its ability to dive beneath American sonar nets, sprint at speeds no torpedo could match, and detonate near a simulated coastal target. Success would validate 9 years of work. Failure was unacceptable. But what they didn't know was that metallurgical flaws in the reactor cooling pipes had passed inspection. Microscopic stress fractures invisible to standard testing. The extreme pressures at operational depth would turn those fractures into catastrophic failures. At 4:11 a.m., Belgorod reached launch depth, 400 meters below the surface. Outside temperature, 2 degrees Celsius. Pressure, 40 atmospheres. Volkov ordered final systems check. Engineering reported all green. Weapons officer confirmed Poseidon Unit 3 ready for deployment. The submarine slowed to 3 knots. Perfect launch conditions. What's your weapon of choice? Type A for unstoppable nuclear torpedoes. Type B for traditional missile systems. Launch sequence initiated at 4:14 a.m. Poseidon's nuclear reactor achieved criticality. Coolant pumps engaged. Power output climbed to 40 megawatts. The weapon's guidance system activated. Pre-programmed route loaded. Target coordinates: simulated enemy harbor 200 kilometers southwest. Tube flooding commenced. Outer door opened. At exactly 4:17 a.m., compressed air ejected the 100-ton weapon from the submarine. For 6 seconds, everything performed perfectly. Poseidon's reactor ramped to full power. The weapon dove to 600 meters. Speed increased to 40 knots, 60 knots, 80 knots. The Torpedo became the fastest underwater object in military history. Sonar tracking from Belgorod confirmed trajectory. The crew celebrated. Russia's superweapon was proving its capabilities. Then, the cooling system failed. A stress fracture in the primary coolant line ruptured at 4:17:34 a.m. Liquid sodium-potassium coolant sprayed into the reactor chamber at 400 degrees Celsius. The weapon's automated safety systems detected the failure instantly. Emergency protocols engaged. But the Poseidon was designed for endurance, not abort procedures. The reactor couldn't achieve rapid shutdown while maintaining propulsion. Reactor temperature spiked from 450 degrees to 890 degrees in 2.4 seconds. Control rods deployed automatically. Too slow. Coolant pressure dropped catastrophically. The nuclear reaction began accelerating beyond design parameters. The weapon's computer had three options: continue to target and risk meltdown, surface and expose the failure, or execute emergency protocols never tested in live conditions. At 4:17:38 a.m., Poseidon's guidance system made a decision that saved 89 Russian sailors. The Torpedo reversed course, heading back toward Belgorod at 95 knots. Not an attack. A desperate attempt to surface before reactor breach. The weapon's programming prioritized preventing nuclear detonation over mission completion. But that meant a runaway nuclear torpedo was now racing toward its launch submarine. Belgorod's sonar operator detected it immediately. Contact bearing 240 degrees. Speed 95 knots. Range 2,100 meters and closing. He reported to the captain with voice shaking. Volkov understood instantly. The weapon was coming back, and it was accelerating. Standard procedures didn't cover this scenario. There was no doctrine for evading your own superweapon. The submarine's maximum speed was 32 knots. Poseidon traveled at 95 knots. Simple math produced a terrifying conclusion. They couldn't outrun it. Diving deeper wouldn't help. The Torpedo could exceed 1,000 meters. Surfacing would take too long. Volkov had seconds to make impossible decisions. He ordered emergency ballast blow. The submarine would rise as fast as physics allowed. Simultaneously, he commanded active countermeasures. Launch decoys, activate jammers, create as much acoustic confusion as possible. Maybe the damaged Torpedo's guidance system would lock onto false targets. Maybe they'd buy precious seconds. Poseidon closed to 1,400 meters. Its reactor temperature reached 1,240 degrees, far beyond safe operational limits. The weapon's hull began deforming under thermal stress. Coolant continued spraying. The nuclear reaction approached criticality threshold. If the reactor achieved uncontrolled chain reaction, the resulting explosion wouldn't be 2 megatons, but it would be enough to vaporize everything within 300 meters and irradiate the Barents Sea for decades. Range, 800 meters. Belgorod climbed at maximum ascent rate. Depth, 340 meters, 310 meters, 280 meters. The submarine's hull groaned under rapid pressure changes. Men grabbed support as the vessel angled 35 degrees upward. Poseidon adjusted its trajectory, still closing, still accelerating despite reactor damage. At 600 meters range, the Torpedo's guidance system experienced catastrophic failure. Thermal damage corrupted computer memory. Navigation algorithms collapsed. The weapon lost target discrimination. It began spiraling in expanding circles, still moving at 85 knots, still carrying a reactor approaching meltdown, but no longer pursuing Belgorod with precision. Volkov saw the erratic sonar track. Opportunity, death spiral. The weapon might pass by them, or it might circle back randomly. He ordered the submarine to maintain ascent, but shift heading 90 degrees. put distance between them and the dying torpedo. Every second mattered. Every meter of separation improved survival odds. Depth: 180 meters. Poseidon's reactor temperature hit 1,890 degrees. The weapon's outer hull ruptured in 3 locations. Seawater flooded internal compartments. The nuclear reactor achieved emergency shutdown as coolant loss became total. But residual heat was enough to melt through remaining containment. Radioactive material began venting into the ocean. At 4:18:11 a.m., exactly 37 seconds after coolant failure began, Poseidon's structural integrity collapsed completely. The torpedo broke apart at 240 meters depth. The nuclear reactor core, no longer contained by pressure hull, experienced rapid cooling from seawater contact. Steam explosion, not nuclear detonation, but violent enough to create a shockwave detectable 40 kilometers away. Belgorod was 370 meters from the disintegration point. The pressure wave hit the submarine's stern like a hammer. Crew members thrown against bulkheads. Light fixtures shattered. Systems alarms screamed throughout the vessel. But the hull held. Double titanium construction absorbed the impact. Volkov's emergency ascent had created just enough separation. 370 meters instead of 40 meters. The difference between catastrophic damage and survivable shock. What would you have done when your own superweapon turned back toward you? Comment your answer below. The submarine surfaced at 4:19 a.m. Emergency protocols required radiating distress signal immediately. But Volkov faced different calculations. Surfacing revealed their position, exposed the test failure, proved Russia's ultimate weapon had nearly killed its own crew, and NATO submarines were always listening. He ordered damage assessment first. Engineering teams reported throughout the boat: propulsion, functional; navigation, operational; life support, normal; hull integrity, compromised in 3 minor sections but sealable; casualties, 14 injured, none critical. The submarine could submerge again, could return to base under its own power. The question was whether to report the incident immediately or maintain operational security. Moscow made that decision for him. Northern Fleet Command had detected the acoustic signature of Poseidon's disintegration. They knew something catastrophic had occurred. Within 8 minutes, encrypted communication demanded status report. Volkov provided sanitized version. Weapon malfunction during test. Submarine intact. Crew safe. No nuclear detonation. The radioactive debris settled across 4 square kilometers of ocean floor. Poseidon's reactor core, now cold and inert, lay in pieces at 380 meters depth. Radiation levels spiked to 470 millisieverts per hour at the disintegration point. Lethal to humans in 2 hours of direct exposure, but contained by seawater. No surface contamination, no atmospheric release. The environmental impact would be localized, significant, but not catastrophic. U.S. Navy surveillance detected the incident through multiple channels. SOSUS hydrophone arrays registered the explosion. Satellite infrared sensors tracked Belgorod's emergency surface. Signals intelligence intercepted Russian emergency communications. Within 90 minutes, National Security Council received briefing. Russia's superweapon had failed spectacularly and nearly irradiated its own submarine. The Pentagon's reaction was classified, but analysts understood the implications immediately. Poseidon's technological challenges exceeded Russian engineering capabilities. The weapon system had fundamental design flaws. Putin's most fearsome doomsday weapon was more dangerous to its operators than its targets. American strategic planning could adjust accordingly. Russia's official response came 6 days later. Brief statement from Defense Ministry. Routine submarine exercise in Barents Sea. All personnel safe, no environmental impact, no mention of Poseidon, no acknowledgement of weapon test. The incident disappeared from Russian military records as if it never happened. But submarine crews knew the truth. Word spread through Northern Fleet. Poseidon nearly killed 89 sailors. The weapon designed to destroy American cities couldn't complete a simple test without catastrophic malfunction. Morale impact was immediate. Submariners questioned other advanced weapons programs. If Poseidon failed, what about Zircon hypersonic missiles? Burevestnik nuclear cruise missiles? Status 6 was supposed to be mature technology, ready for operational deployment. Instead, it was revealed as dangerous prototype that endangered its own operators. Development program faced immediate consequences. Chief engineer reassigned, quality control director fired, entire reactor design team replaced. But fundamental problems remained. Miniaturizing nuclear reactors into torpedo bodies created unsolvable trade-offs. You could have power, you could have reliability. You couldn't have both in 24-meter package traveling at 100 knots underwater. Budget allocations shifted quietly. Poseidon funding reduced by 37% in next fiscal year. Resources redirected to conventional weapons with proven performance. Submarine construction continued, but Belgorod's sister ships wouldn't carry the superweapon. They'd be reconfigured for traditional strategic missiles, less dramatic, but functional. Western intelligence assessed the failure's strategic significance. Russia had invested $47 billion in weapons system that couldn't reliably complete test runs. The supposed trump card in nuclear standoff was exposed as expensive failure. Deterrence calculations shifted. NATO planners reduced priority for Poseidon-specific countermeasures. If Russia couldn't field working weapons, extensive defensive preparations were unnecessary. Support this channel's detailed military analysis by hitting that subscribe button and bell icon. These investigations take serious resources to research and produce. The Barents Sea incident revealed deeper problems in Russian military development. Pressure to produce wonder weapons exceeded engineering realities. Political leadership demanded capabilities technology couldn't deliver. The result was systems like Poseidon, impressive on paper, deadly unreliable in operation. Russia was building weapons to impress audiences, not win wars. Volkov received quiet commendation for saving his crew. Also, unofficial reprimand for losing the weapon. Military politics demanded someone bear responsibility. His career effectively ended despite correct decisions under impossible circumstances. He requested transfer to training command. Granted immediately. The Navy wanted him away from operational submarines. Too much direct knowledge of embarrassing failure. The 14 injured sailors recovered within weeks. Minor fractures, concussions, bruising, physical wounds healed quickly. Psychological impact lasted longer. They had felt their own weapon hunting them. Experienced terror of being prey instead of predator. Every subsequent patrol carried that memory. Poseidon represented technological marvel designed to project power. Instead, it became cautionary tale about hubris exceeding capability. China watched the incident with intense interest. Their own nuclear torpedo programs received immediate safety reviews. If Russia couldn't solve the technical challenges, could Chinese engineering do better? Several projects received additional scrutiny. Some were quietly suspended. Learning from others' failures prevented repeating costly mistakes. American submarine doctrine absorbed lessons quickly. Focus shifted from defending against theoretical superweapons to exploiting Russian technical limitations. If their advanced systems failed during tests, they'd fail during combat. Confidence in American technological advantages increased. The deterrence equation stabilized in U.S. favor. Years of propaganda about unstoppable weapons collided with reality. Poseidon was supposed to make American coastal defenses obsolete. Instead, it nearly killed its own submarine crew during routine test. The gap between Russian claims and Russian capabilities widened visibly. Future weapons announcements would receive more skepticism from international observers. Was this weapon failure a temporary setback, or proof that doomsday torpedoes are fundamentally flawed? Leave your thoughts in the comments. Modern warfare rewards reliability over revolutionary capabilities. A conventional torpedo that works 99% of the time beats superweapon that fails catastrophically 10% of the time. Russian military strategy prioritized dramatic capabilities over practical effectiveness. The consequences played out 370 meters from total disaster in the Barents Sea. The radioactive debris remains on the ocean floor today, too deep for easy recovery, too dispersed to justify cleanup operation. Eventually, currents will scatter contaminated material across larger area. Radiation will decay slowly over decades. Future marine surveys will detect anomalous readings, another legacy of weapons programs that promised too much and delivered catastrophe. For the 89 sailors aboard Belgorod, November 8, 2024, marked the day they survived their own military superweapon. They had 11 seconds between coolant failure and potential meltdown. Those seconds define difference between returning to port or becoming radioactive tomb at 400 meters depth. Technical training, quick decisions, and 370 meters of separation saved them, not the advanced weapon system they were testing. If you're still watching, you're exactly the kind of viewer who makes this channel possible. Like this video, share it with anyone interested in real military capabilities versus propaganda, and subscribe so you never miss our next deep dive into the weapons shaping global power dynamics. Russia continues developing Poseidon despite the failure. Official statements claim improvements implemented, safety systems enhanced, reactor design refined. But submariners know what happened in the Barents Sea. They remember the weapon that turned back toward its launch platform. They understand the difference between political promises and engineering reality, and they question whether the next test will end differently. Because when your ultimate weapon becomes your worst threat, the entire concept of deterrence requires rethinking. Power isn't measured by the weapons you claim to possess. It's proven by the systems that actually work when everything depends on them.